For most of human history, dogs have lived beside us so closely that we rarely stop to question just how strange that relationship really is. Yet if you look closely, the abilities dogs display can feel almost impossible to explain. Around the world, there are thousands of documented cases of dogs detecting cancer long before doctors discover it, sometimes identifying the disease simply by smelling a person's breath or skin. In hospitals and research labs today, trained dogs can walk past rows of medical samples and accurately identify which one belongs to a patient with a hidden illness. In some experiments, they have even detected infections like COVID-19 faster than laboratory tests. These are not stories passed down through folklore or exaggeration, but results documented by scientists who are trying to understand how a creature that once hunted in wild wolf packs developed senses powerful enough to detect disease inside the human body. But the mysteries do not stop there. Many dog owners have experienced a moment that seems equally difficult to explain. A dog suddenly runs to the door and begins waiting, sometimes minutes before its owner arrives home, even when that arrival time changes every day. Researchers studying this behavior have found that dogs can anticipate human actions in ways that appear almost like prediction. Some dogs alert their owners before epileptic seizures begin, while others warn diabetics before blood sugar levels drop to dangerous levels. In certain cases, dogs have reacted to storms or earthquakes before humans were even aware that something was about to happen. Whether these behaviors come from extraordinary senses, an ability to read subtle signals in the environment, or something we still do not fully understand, they reveal a level of awareness that challenges the way we think about animals. Even more surprising is how deeply dogs seem to understand us. Experiments conducted at major research universities have shown that dogs can interpret human gestures, facial expressions, and tone of voice with astonishing accuracy. In some cognitive tests, dogs actually outperform chimpanzees at understanding human pointing gestures. Certain dogs have learned the names of hundreds of objects and can retrieve them on command, demonstrating memory and reasoning abilities once believed to belong only to humans and primates. Brain imaging studies have even revealed that dogs process human voices in specialized regions of their brains, suggesting that after thousands of years living beside us, their minds may have evolved specifically to understand our signals. Yet when you step back and consider the deeper story, the most remarkable mystery may not be what dogs can do, but how they came to exist in the first place. Dogs did not simply appear alongside human civilization. They descended from wolves, powerful predators that once competed with humans for survival across the Ice Age landscape. Somewhere in the distant past, something extraordinary happened between these two species. Instead of remaining rivals, certain wolves began approaching human camps, and over generations, those wolves slowly transformed into something entirely new. That transformation would eventually create an animal capable of hunting with humans, protecting human communities, sensing human emotions, and forming bonds so strong that people often describe dogs as family. Today, there are more than 900 million dogs living on Earth, sharing homes, cities, and lives with humans across nearly every culture on the planet. They guide the blind through crowded streets, search disaster zones for survivors, detect hidden diseases in hospitals, and greet their owners with unmistakable excitement every time they return home. Yet even after thousands of years together, scientists are still uncovering new discoveries about how dogs think, what they feel, and how they perceive the world around them. Because once you begin to look closely, the everyday behaviors of dogs start to reveal a much deeper story. A story about an ancient partnership between two species that changed the course of history. A story about senses far beyond human perception, intelligence shaped by thousands of years of cooperation, and a bond so powerful that it reshaped both human civilization and the animal that chose to live beside us. And when you follow that story all the way back to the beginning, it raises a question that scientists are still trying to answer today. Out of all the animals that have ever lived on Earth, how did one ancient predator become the only species that truly learned to understand us? Chapter 1. Dogs that can smell disease. The story begins in a place where few people would expect to find one of the most astonishing abilities in the animal kingdom, a medical laboratory. In the late 1980s in the United Kingdom, a woman named Claire Guest noticed something strange about the way her dog behaved around a small mole on her skin. The dog repeatedly returned to the same spot, sniffing it intensely and even nudging it with its nose. At first, the behavior seemed random, but it became persistent enough that she eventually decided to have the mole examined by a doctor. The diagnosis came as a shock. The mole was malignant melanoma. Only later did she begin to wonder whether the dog had been reacting to something invisible to human senses. At the time, the idea that a dog could smell cancer sounded almost unbelievable. Yet around the same period, doctors began noticing similar reports appearing in medical literature. In 1989, a brief but intriguing letter was published in the journal The Lancet describing a case in which a dog repeatedly sniffed and even attempted to bite a woman's skin lesion through her clothing. Concerned by the unusual behavior, she sought medical advice. The lesion was later confirmed to be melanoma. What made the case particularly fascinating was that the dog had shown interest in the exact spot where the cancer was developing. For scientists, this raised a strange possibility that had rarely been explored before. Could dogs detect disease simply by smell? To understand how this might be possible, researchers began studying the extraordinary anatomy of the canine nose. Dogs possess one of the most advanced scent detection systems found in any animal. While humans have roughly 6 million olfactory receptors in the nose, dogs can have up to 300 million depending on the breed. The difference does not end there. The region of the brain responsible for analyzing scent is proportionally about 40 times larger in dogs than in humans. Even the structure of a dog's nose is designed for scent analysis. When a dog inhales, the airflow splits into separate channels. One pathway allows the animal to breathe normally, while another directs odor molecules into specialized scent chambers where they can be analyzed in remarkable detail. Scientists at institutions such as the University of Pennsylvania, Working Dog Center, and research groups around the world began examining how dogs process these chemical signals. Human cells constantly release microscopic molecules into the air known as volatile organic compounds. When diseases such as cancer alter cellular metabolism, the pattern of these molecules changes slightly. These chemical changes are usually far too subtle for humans to detect. But for a dog's nose, even minute variations in scent can stand out clearly. In essence, disease may produce a faint chemical fingerprint that trained dogs can learn to recognize. By the early 2000s, researchers began conducting controlled scientific experiments to test whether this ability was real. One of the earliest widely cited studies took place in 2004 at the Pine Street Foundation in California. Scientists trained several dogs to analyze breath samples from patients. During blind trials, the dogs were presented with rows of containers holding breath samples from both healthy individuals and cancer patients. Remarkably, the animals correctly identified many of the cancer samples. In some cases, they detected lung and breast cancer with accuracy levels that surprised even the researchers conducting the experiments. Similar work soon appeared in other parts of the world. In Japan, researchers led by Hideto Sonoda at Kyushu University conducted experiments showing that trained dogs could detect colorectal cancer using both breath and stool samples. These studies suggested that tumors release unique chemical compounds that circulate through the body and eventually reach the skin, breath, or bodily fluids. For a dog trained to recognize those compounds, the scent signature could be unmistakable. As these findings accumulated, a new field began to emerge. Medical detection dogs. Organizations around the world started training dogs specifically for this purpose. One of the best known is Medical Detection Dogs, founded by Claire Guest. In controlled laboratory environments, trained dogs walk along rows of sample containers and indicate which one contains the disease marker. Many of these dogs are breeds such as Labrador Retrievers or Spaniels, chosen for their focus, motivation, and strong scent detection abilities. In some trials, these dogs have achieved detection rates above 90% for certain cancers, demonstrating that their noses may be capable of identifying disease long before traditional diagnostic tools. One of the most striking demonstrations of this ability occurred during the global pandemic of COVID-19 beginning in 2020. Scientists wondered whether dogs could detect infection by smelling subtle chemical changes in the human body. Research teams in countries including Finland, Germany, the United Arab Emirates, and the United Kingdom began training dogs using sweat samples from infected individuals. At Helsinki Airport in Finland, specially trained dogs were even deployed to screen arriving passengers. In several trials, the animals correctly identified infected individuals with remarkable speed, sometimes detecting cases even before symptoms appeared. But perhaps one of the most intriguing stories in this field involves a disease that affects the brain rather than the lungs. In Scotland, a woman named Joy Milne noticed something unusual about her husband years before doctors diagnosed him with Parkinson's disease. She detected a distinct musky smell that seemed to appear gradually over time. At first, she assumed it was simply a change in body odor, but the scent became stronger as the disease progressed. When scientists later investigated her observation, they discovered that Parkinson's alters the chemical composition of oils on the skin. Researchers at the University of Manchester have since worked with trained dogs to identify this scent, raising the possibility that Parkinson's might someday be diagnosed years before symptoms begin. Dogs have also proven life-saving for people living with chronic medical conditions. For individuals with type 1 diabetes, sudden drops in blood sugar can occur without warning. If blood sugar levels fall too low, a person may lose consciousness or suffer seizures. Specially trained diabetic alert dogs can detect subtle chemical changes in their owner's breath or sweat that signal falling glucose levels. Organizations such as Dogs for Diabetics train these animals to alert their owners by pawing, barking, or retrieving emergency supplies. Many handlers report their dogs warning them minutes before electronic glucose monitors detect the problem. Another area that remains partly mysterious involves dogs that appear capable of predicting epileptic seizures. Some individuals with epilepsy report that their dogs begin acting strangely minutes before a seizure occurs. The dog may stare intensely, pace nervously, or attempt to alert other people nearby. Scientists are still investigating how this works. One theory suggests that dogs detect subtle changes in body chemistry before a seizure begins. Another possibility is that they perceive tiny behavioral or neurological cues that humans themselves cannot recognize. Research teams at institutions such as the University of Florida and University of Rennes continue to study these phenomena. All of this leads to an obvious question. If dogs can detect disease so effectively, why do we not simply replace them with machines? For decades, engineers have attempted to develop electronic devices, sometimes called artificial noses. These sensors analyze chemical compounds in the air and attempt to identify patterns associated with disease. While the technology has improved significantly, most electronic systems still struggle to match the sensitivity of a dog's nose. Dogs can detect scent molecules at concentrations measured in parts per trillion. They can also adapt quickly to complex mixtures of odors in ways that current technology still finds difficult to replicate. What makes the story even more remarkable is that dogs developed these abilities long before humans understood what disease even was. Thousands of years ago, long before microscopes or laboratories existed, wolves that would eventually become dogs relied on scent to track prey across vast landscapes. That ancient sensory system evolved to analyze incredibly faint chemical trails left behind by animals moving through forests or across open plains. Today, the descendants of those hunters are using the same ability to detect microscopic changes occurring inside the human body. Across hospitals, laboratories, and homes around the world, dogs continue to identify illnesses that doctors sometimes struggle to detect. Their noses can sense invisible chemical signals drifting through the air. Signals that reveal the presence of cancer cells, viruses, or metabolic changes long before machines notice them. It is an ability that can feel almost supernatural when we first hear about it. Yet it emerges from the extraordinary biology of a creature that evolved alongside humans for thousands of years. And this discovery leads to an even more puzzling thought. If dogs can smell diseases hidden deep within the human body, conditions that even modern technology sometimes misses, then their senses may be detecting far more information than we realize. Illness is only one form of chemical change occurring around us every moment, which raises a fascinating possibility. What else might dogs be sensing that humans cannot? And could those hidden signals explain the strange stories of dogs that seem to know when something is about to happen before anyone else does? That question leads directly into the next mystery: dogs that appear to predict events before they occur. Chapter 2: Dogs that know before it happens. One of the most familiar and strangely mysterious moments in everyday life with a dog often begins in complete silence. The house is calm, nothing appears unusual, and yet a dog suddenly lifts its head as if it has noticed something no one else can perceive. A moment later, it stands up, walks toward the front door, and begins waiting expectantly. Minutes later, the sound of a car appears in the driveway and the owner walks through the door. To many dog owners, this scene feels almost routine. It happens so often that people rarely question it. But when scientists began studying the behavior carefully, they realized it raised a fascinating question. How does the dog know someone is coming home before there are any obvious signals? Stories like this appear everywhere. People live with dogs. Owners report their dogs running to the window shortly before family members return from work or school. Sometimes the timing seems almost uncanny, particularly when the arrival time varies from day to day. This behavior has attracted scientific curiosity for decades because it appears to suggest that dogs can anticipate events before they happen. For researchers studying animal cognition, however, the challenge has always been separating true prediction from the remarkable ability animals have to detect patterns in their environment. One of the most widely discussed investigations into this phenomenon took place in the 1990s, led by the British biologist Rupert Sheldrake, who at the time was associated with research work connected to University of Cambridge. Sheldrake became interested in reports from dog owners who claimed their pets could anticipate their return home even when routines changed. In order to test the idea, he began collecting observations and conducting experiments with dogs that reportedly showed this behavior. The most famous of these cases involved a dog named JT and his owner Pam Smart in England. According to Smart, JT frequently began waiting by a window at the exact moment she decided to head home, even when her schedule varied significantly. In some tests, Smart left work at random times chosen by independent observers to avoid predictable patterns. Cameras recorded JT's behavior while she was away. In some trials, the dog appeared to begin waiting near the window well before she arrived. These observations sparked widespread discussion about whether dogs might possess some unexplained awareness of their owner's intentions. However, the scientific community approached the findings cautiously. Critics pointed out that animals are extremely sensitive to routine cues that humans may overlook. even subtle signals in the environment, such as neighborhood traffic patterns, distant car sounds, daily rhythms of light, or activity levels in a house, could potentially signal when someone is likely to return. Dogs may also develop internal expectations based on time and habit. Over months or years of living with the same family, a dog can memorize complex daily patterns that guide its behavior. Modern researchers increasingly believe that dogs excel at detecting patterns humans barely notice. A dog living in a household experiences thousands of small cues every day. The time when lights usually turn on, the typical hour when footsteps approach outside, the scent changes in the air when people begin traveling home from nearby locations. These signals accumulate into a detailed mental map of daily life. Because dogs rely so heavily on smell and sound, they may detect these environmental changes long before humans consciously recognize them. But predicting routine events is only part of the story. In medical situations, dogs sometimes appear to anticipate events that even doctors struggle to predict. One of the most dramatic examples involves seizure-alert dogs. Individuals living with epilepsy have reported that their dogs sometimes begin behaving strangely shortly before a seizure occurs. The dog may pace nervously, bark repeatedly, paw at the person, or attempt to lead them to a safe place. These alerts can occur several minutes before the seizure begins, giving the person time to sit down or call for help. Researchers studying this phenomenon at institutions such as the University of Florida College of Veterinary Medicine have investigated how dogs might detect these episodes. One leading hypothesis is that the body releases subtle chemical signals before neurological changes trigger a seizure. Because dogs possess an extremely sensitive sense of smell, they may detect these scent changes early. Another possibility is that dogs observe tiny behavioral cues, perhaps a slight change in posture, muscle tension, or breathing pattern that precede the seizure. In either case, the dog is reacting to signals that humans themselves cannot easily perceive. Beyond medical prediction, animals including dogs have long been associated with unusual behavior before natural disasters. Throughout history, people have described animals acting restless or frightened before earthquakes. One of the most famous cases occurred prior to the 1975 Haicheng earthquake in northeastern China. Residents reported strange behavior among animals in the days leading up to the quake, including dogs barking intensely, refusing to enter buildings, and running away from their homes. Although such reports are largely anecdotal, scientists know that animals can detect environmental signals humans cannot perceive. Dogs may be sensitive to extremely faint ground vibrations that precede earthquakes. They may also detect changes in static electricity in the atmosphere or variations in underground gas emissions released from shifting rock layers. Because dogs can hear frequencies far beyond the human hearing range, they might detect low-frequency rumbling sounds traveling through the ground long before humans feel any tremors. While researchers continue to study these possibilities, the consistent reports of unusual animal behavior suggest that dogs may be responding to early environmental warnings. Dogs also appear to anticipate storms well before they arrive. Many dog owners notice their pets becoming restless hours before thunderstorms begin. Dogs may pace, hide, whine, or stay unusually close to their owners. One explanation involves atmospheric pressure changes. As a storm approaches, barometric pressure drops and electrical charges build in the air. These subtle shifts can affect animals with sensitive sensory systems. Dogs may also hear distant thunder vibrations long before humans notice them, because their hearing range extends into lower frequencies. Another powerful area of research involves emotional prediction. Dogs constantly observe the people around them, gathering information from facial expressions, body posture, voice tone, and movement patterns. Scientists studying canine cognition have discovered that dogs are remarkably skilled at interpreting these signals. Experiments conducted at the University of Helsinki have shown that dogs respond differently when viewing images of human faces expressing happiness, anger, or fear. The dogs tend to focus more intensely on threatening expressions and display measurable changes in stress levels. These abilities allow dogs to detect emotional changes in humans before words are spoken. A slight tightening of facial muscles, a change in breathing rhythm, or subtle tension in posture may signal that a person is anxious or upset. Because dogs are constantly monitoring these signals, they often react before humans consciously express their emotions. To an observer, it can seem as if the dog somehow knows what someone is feeling before the person even says anything. Military working dogs provide another dramatic example of how sensitive dogs can be to environmental signals. During conflicts in Iraq and Afghanistan, specially trained dogs worked alongside soldiers to detect explosives hidden in vehicles or buried along roads. These dogs rely primarily on scent detection, identifying trace chemical particles from explosive materials. However, handlers frequently reported that their dogs sometimes reacted to potential threats before humans noticed anything unusual. The dogs might freeze suddenly, change posture, or focus intensely on a particular area, alerting soldiers to danger. Part of this ability likely comes from the dog's incredible sense of smell, but it also reflects their awareness of subtle environmental changes. Dogs can detect unusual scents, altered ground surfaces, or faint chemical traces drifting through the air. They may also respond to the tension or behavior of nearby humans. In complex environments where many small signals overlap, dogs can integrate sensory information quickly and react faster than people. Scientists have also explored how dogs detect hormonal changes in humans. When people experience stress or fear, the body releases hormones such as cortisol and adrenaline. These chemicals influence the composition of sweat and skin oils, producing subtle changes in scent. Because dogs can detect extremely small concentrations of odor molecules, they may perceive these changes instantly. This ability allows dogs to recognize when a person is anxious, frightened, or about to experience a panic attack. When researchers step back and examine all of these observations together, a pattern begins to emerge. Dogs are constantly analyzing signals in their environment. Signals that include scent, sound, vibration, movement, and even emotional cues from humans. What sometimes appears to be supernatural prediction may actually be the result of extraordinary sensory awareness, combined with pattern recognition developed over thousands of years of evolution. Dogs live in a world saturated with information that humans simply cannot perceive. The air carries chemical messages drifting from bodies and objects. The ground vibrates with distant movement. Subtle changes in posture and expression reveal emotional states before words are spoken. For a dog, these signals form a continuous stream of data describing what is happening and what might happen next. Faint signals and combining them with faint signals and combining them with memory of past patterns, dogs can anticipate events with remarkable accuracy. They know when routines are about to unfold, when a storm is approaching, when a person is becoming anxious, and sometimes even when a medical event is about to occur. And this realization leads to an even deeper question. If dogs are so skilled at reading human behavior and emotional cues, then their relationship with humans must involve something more than simple companionship. Over thousands of years, dogs appear to have developed an extraordinary ability to interpret human communication. Understanding how that happened reveals one of the most surprising discoveries in animal cognition. Dogs may understand humans better than almost any other species on Earth. Chapter 3. How dogs read human minds. For much of the 20th century, scientists believed that if any animals were capable of understanding human communication, it would almost certainly be our closest evolutionary relatives. Chimpanzees, bonobos, and other primates share a large portion of our DNA, use tools, and demonstrate impressive problem-solving abilities. Because of this, researchers assumed that primates would be the species most capable of interpreting human gestures and social cues. Dogs, by contrast, were long viewed primarily as domesticated working animals rather than sophisticated interpreters of human behavior. Yet, as researchers began conducting experiments in animal cognition during the late 1990s and early 2000s, a surprising pattern emerged. In certain social intelligence tests, dogs consistently outperformed chimpanzees, revealing an unexpected specialization that scientists had overlooked for decades. One of the most influential researchers responsible for uncovering this discovery is Brian Hare, who began studying animal cognition while working at Harvard University before later founding the Duke Canine Cognition Center in North Carolina. Hare designed a deceptively simple experiment intended to measure how animals interpret human gestures. 2 containers were placed on the floor in front of the test animal. One container held food, while the other remained empty. A human researcher then pointed toward the container containing the reward. The test measured whether the animal would understand that the pointing gesture was intended to communicate the location of the food. When chimpanzees were presented with this task, the results were surprisingly inconsistent. Although chimpanzees are extremely intelligent in many areas, they often ignored the pointing gesture entirely or relied on their own guesses. Some even attempted to solve the problem independently without paying attention to the human signal. Dogs, however, produced dramatically different results. Most dogs followed the pointing gesture immediately and moved directly toward the correct container. Even puppies, only a few months old, demonstrated the same ability. This suggested that dogs possess an unusually strong instinct to interpret human gestures as meaningful communication. The implications of these findings were striking. Unlike primates, dogs do not share our evolutionary ancestry in the same way. Yet they appear to have developed a specialized ability to read human signals. Scientists began to suspect that domestication may have played a crucial role in shaping this ability. Over thousands of years, living alongside humans, dogs may have evolved cognitive traits specifically suited for interpreting human behavior. This sensitivity to human communication extends far beyond simple gestures. Some dogs have demonstrated remarkable abilities to understand human language. One of the most famous examples was a border collie named Chaser, trained by psychologist John Pilley in South Carolina. Over several years of careful training and testing, Chaser learned the names of more than 1,000 individual objects. Each toy in her collection had a unique name, and Chaser could retrieve specific items when asked. When Pilley requested a particular toy, Chaser could search through hundreds of objects and select the correct one based solely on the spoken word. What made this achievement especially fascinating was not simply the number of words Chaser learned, but the way she learned them. Her training suggested that dogs can form associations between spoken words and physical objects in a manner somewhat similar to how children learn vocabulary. When presented with a group of toys that included one unfamiliar object, Chaser could sometimes infer the name of the new object through a process known as exclusion learning. If she already knew the names of all the other toys, the unfamiliar word must correspond to the unfamiliar object. Similar experiments have been conducted at the Max Planck Institute for Evolutionary Anthropology, where scientists have studied dogs capable of learning dozens or even hundreds of words. In controlled tests, some dogs demonstrated the ability to deduce the names of new objects without direct training, suggesting that their cognitive abilities may include forms of reasoning that were once thought unique to humans. Dogs are also remarkably sensitive to the emotional qualities of human speech. Researchers at Eötvös University conducted groundbreaking studies using functional MRI scans on awake dogs. In these experiments, dogs were trained to lie calmly inside an MRI scanner while researchers played recordings of human voices. the scans revealed that dogs possess brain regions that respond specifically to vocal tones. These regions allow dogs to distinguish between positive praise, neutral speech, and negative or threatening tones. This means that when a person speaks to a dog, the animal is not only hearing the words themselves, but also interpreting the emotional information embedded in the voice. Dogs appear to process these emotional signals in ways that closely resemble how humans interpret tone and intention in speech. This ability helps explain why dogs often respond more strongly to the emotional tone of a sentence than to the specific words being spoken. Vision also plays an important role in how dogs interpret humans. Experiments conducted at Kyoto University have demonstrated that dogs can recognize individual human faces and remember them over long periods of time. When presented with images of their owners and strangers, dogs display different patterns of attention and emotional response. In many cases, they focus longer on familiar faces, suggesting that they are capable of recognizing specific individuals visually as well as through scent. Perhaps one of the most remarkable discoveries about the human-dog relationship involves a chemical process inside the brain. Researchers led by Miho Nagasawa discovered that when dogs and humans gaze into each other's eyes, both species experience an increase in the hormone oxytocin. Oxytocin is often referred to as the bonding hormone because it plays a major role in forming emotional attachments between people, particularly between parents and infants. This discovery suggests that the bond between humans and dogs is reinforced by biological mechanisms similar to those involved in human family relationships. When a dog looks into its owner's eyes and receives attention or affection, both the human and the dog experience a surge of oxytocin that strengthens the emotional connection between them. In a sense, the relationship between humans and dogs is supported by a shared hormonal feedback loop that encourages trust and attachment. Dogs also demonstrate a remarkable ability to learn human routines. Living alongside people exposes dogs to countless patterns in daily life. They observe when humans wake up, when meals are prepared, when people leave for work, and when certain activities typically occur. Over time, dogs assemble these patterns into complex mental maps that allow them to anticipate events such as walks, car rides, or feeding times. Because dogs are constantly observing human behavior, they become experts at predicting what people are likely to do next. Comparisons between dogs and wolves provide additional clues about how this ability developed. Studies conducted by Hungarian animal behaviorist Adam Miklosi have compared domesticated dogs with wolves raised by humans under similar conditions. Even when wolves are socialized with humans from a young age, they typically struggle to interpret human gestures as effectively as dogs. Dogs follow pointing signals more reliably and respond more strongly to human eye contact and voice cues. These findings suggest that domestication fundamentally altered the way dogs think about humans. Over thousands of years, wolves that were more tolerant of human presence may have gradually developed traits that favored cooperation with people. As humans selectively bred dogs for companionship, hunting, herding, and guarding, animals that were especially skilled at reading human behavior likely had an advantage. Over many generations, this process may have shaped the dog's mind into a system uniquely adapted for understanding human social signals. Another fascinating aspect of canine cognition involves empathy. Experiments conducted at University of London explored how dogs respond to human emotional distress. In these studies, volunteers pretended to cry while sitting in a room with a dog. Many dogs responded by approaching the crying person and attempting to comfort them, even if the person was unfamiliar. Dogs often displayed behaviors such as licking, nuzzling, or resting their heads against the person's body. These reactions suggest that dogs are sensitive to emotional cues associated with human distress. While scientists debate whether dogs truly experience empathy in the same way humans do, it is clear that they respond strongly to signals indicating sadness or anxiety. Because dogs constantly monitor facial expressions, voice tone, posture, and scent, they may detect emotional states long before people verbally express them. Taken together, these discoveries reveal a powerful conclusion. Dogs are not simply intelligent animals in the general sense. Instead, they appear to be specialists in understanding humans. Their cognitive abilities are particularly well suited to interpreting the signals humans use to communicate. Gestures, facial expressions, tone of voice, routines, and emotional cues. In many of these areas, dogs outperform animals that are otherwise considered more traditionally intelligent. This specialization likely emerged through thousands of years of shared history. As humans and early dogs lived and worked together, animals that could interpret human behavior effectively were more successful companions. Over time, this partnership shaped the evolution of both species. Humans gained a loyal and capable partner in hunting, protection, and companionship. Dogs gained access to food, shelter, and a social bond unlike any other relationship in the animal kingdom. By the time we look at modern dogs today, we are not simply observing animals that have learned to live alongside humans. We are observing a species whose minds have been shaped by generations of interaction with us. Dogs watch our faces, listen to our voices, read our body language, and detect emotional signals in ways that few other animals can match. And yet the story does not end with how dogs interpret human behavior. If dogs are constantly reading our signals, they are also sending signals of their own. Every movement of a tail, every shift in posture, every bark, whine, or tilt of the head carries information. Dogs communicate with one another and with humans through a complex system of body language that many people only partially understand. The next chapter turns to that hidden system of communication. Beneath the familiar behaviors we see every day lies a sophisticated language of posture, movement, and expression, a secret language dogs use to speak to both humans and other animals. Chapter 4. The Hidden Language of Dog. Long before scientists began studying canine behavior in laboratories, people who lived and worked closely with dogs already understood that dogs communicate constantly without speaking a single word. Hunters following their dogs through forests, shepherds guiding flocks across mountain pastures, and farmers relying on working dogs to guard livestock all learned to read small signals that revealed what their dogs were sensing in the environment. A slight shift in posture could mean the dog had detected movement. A stiff tail could signal tension or alertness. A lowered body might indicate caution or submission. These signals formed a silent conversation between humans and dogs, a language made entirely of movement, posture, and expression rather than sound. What many people interpreted simply as instinct or personality was actually a sophisticated system of communication. Dogs are social animals that evolved to live in groups, and social animals depend on communication to maintain cooperation and avoid conflict. Because dogs lack spoken language, they rely on visual signals, vocal sounds, and scent cues to share information. Every moment a dog interacts with the world, it is both sending and receiving signals about emotion, intention, and awareness of its surroundings. Over time, people who lived closely with dogs learned to interpret these signals intuitively, even if they did not fully understand the biological mechanisms behind them. The scientific study of canine communication began to take shape in the mid-20th century with the rise of a field known as ethology, the biological study of animal behavior. One of the earliest pioneers in this field was Konrad Lorenz, an Austrian scientist whose work on animal behavior helped establish ethology as a scientific discipline. Lorenz and other early researchers began documenting how animals communicate through posture, movement, and ritualized signals. Their observations revealed that many animal behaviors that appear random are actually structured forms of communication designed to prevent conflict or strengthen social bonds. Later, researchers built on these ideas to better understand canine body language. Among the most influential voices in modern dog behavior research is Turid Rugas, who introduced the concept of what she called calming signals. According to Rugas, dogs frequently use small, subtle gestures to communicate peaceful intentions and avoid confrontation. These gestures can include turning the head away, licking the nose, blinking slowly, yawning, or moving slowly rather than abruptly. To humans, these behaviors often appear meaningless or random. But in the social world of dogs, they function as polite signals that say, in effect, "I'm not a threat." Understanding calming signals can completely change the way people interpret dog behavior. For example, when a dog turns its head away during a tense interaction, it is not ignoring the situation. Instead, it may be attempting to diffuse tension by signaling that it does not wish to escalate the encounter. Similarly, a dog that begins licking its lips or blinking slowly during a stressful moment may be communicating anxiety or attempting to calm both itself and others nearby. These subtle gestures illustrate how much information dogs exchange without making a sound. One of the most widely misunderstood signals in canine communication involves the wagging tail. Many people assume that a wagging tail simply means a dog is happy. In reality, tail movement conveys a wide range of emotional information. The height of the tail, the speed of the wag, and even the direction of movement can signal different emotional states. Researchers studying canine behavior have discovered that dogs wag their tails more strongly toward the right side when experiencing positive emotions, such as excitement when seeing their owner. When confronted with something stressful or unfamiliar, dogs tend to wag more toward the left side. This phenomenon was explored in experiments conducted at the University of Trento, where scientists measured subtle asymmetries in tail movement. The results suggested that tail wagging may be connected to different emotional processing regions in the brain. Because other dogs can perceive these subtle differences in movement, tail wagging may serve as a form of emotional signaling within canine social groups. Ear position is another important element of canine communication. Dogs constantly adjust their ears both to gather information from their surroundings and to signal their emotional state. In breeds with upright ears, the ears typically move forward when the dog is alert or curious. When the ears flatten backward, the dog may be experiencing fear, submission, or uncertainty. Even in breeds with floppy ears, subtle movements of the head and neck convey similar information. Because dogs possess highly sensitive hearing, ear orientation also allows them to pinpoint sounds in the environment while simultaneously expressing their mood. Prolonged eye contact as a threat to prolonged eye contact, as a threat to dominance within the group. Domestic dogs, however, have developed a somewhat different relationship with eye contact when interacting with humans. Gentle eye contact between a dog and its owner can strengthen social bonds and reinforce trust. Studies conducted at Azabu University have shown that mutual gazing between dogs and their owners increases levels of oxytocin, a hormone associated with bonding and social attachment. Time. They often avoid direct staring, and and instead glance briefly before turning their heads slightly away. This pattern allows them to gather visual information without triggering defensive behavior. Humans who unknowingly stare directly at unfamiliar dogs may accidentally send a signal that the dog interprets as a challenge. Another behavior that often confuses people is licking. Dogs lick human faces, hands, and sometimes even the air around them, and owners frequently wonder what the behavior means. In many cases, licking serves as a greeting or a sign of social bonding. Among wolves, young pups lick the mouths of adult wolves as a submissive gesture and sometimes to encourage adults to regurgitate food. Domestic dogs may retain this instinct, using licking as a way to express respect or affection toward humans and other dogs. Licking also allows dogs to gather chemical information through taste and smell. The surface of human skin carries traces of sweat, oils, and other compounds that reveal information about health and emotional state. By licking, dogs can collect additional sensory data about the individuals around them. This behavior reflects the way dogs experience the world through scent and chemical signals far more intensely than humans do. Although body language forms the foundation of canine communication, vocalizations also play an important role. Dogs use a variety of sounds, including barking, whining, growling, and howling, each of which carries distinct meaning depending on the context. Interestingly, domestic dogs bark far more frequently than wolves do. Wolves primarily use howling to communicate across long distances, while barking is relatively rare among adult wolves. During domestication, however, dogs appear to have developed barking as a way to communicate more effectively with humans. Researchers studying animal vocalization patterns have found that humans can often distinguish between different types of dog barks, even without training. People tend to recognize the difference between an alarm bark, a playful bark, or a lonely bark produced when a dog is isolated. This suggests that dogs have evolved vocal patterns that humans intuitively understand, further strengthening the communication bridge between the two species. Body posture adds another layer to this silent language. A dog leaning forward with its weight shifted toward its front legs often signals curiosity or confidence. A dog crouching low with its tail tucked tightly beneath its body may be communicating fear or submission. One of the most recognizable canine gestures is the play bow, in which a dog lowers its front legs while keeping its hindquarters raised. This posture functions as an invitation to play and signals friendly intentions. Dogs across the world recognize the play bow as a universal signal, indicating that the following actions are meant to be playful rather than aggressive. Communication among dogs also occurs through scent, an aspect of behavior that humans often overlook. Dogs possess scent glands located in various parts of the body, including the paws, face, and base of the tail. When dogs greet each other by sniffing, they are exchanging detailed chemical information. Through scent alone, a dog can learn about another dog's identity, sex, reproductive status, emotional condition, and even recent experiences. Interestingly, dogs often modify their communication depending on whether they are interacting with other dogs or with humans. Studies conducted at the University of Portsmouth have shown that dogs produce more exaggerated facial expressions when humans are watching them. In experiments where food rewards were present, dogs were more likely to raise their eyebrows and alter facial expressions when a person was looking at them compared to when the person was turned away. This suggests that dogs may intentionally adjust their expressions to capture human attention. As scientists continue studying these behaviors, a fascinating pattern emerges. Dogs are constantly engaged in a complex exchange of signals that most humans barely notice. Every tail movement, ear adjustment, glance, posture change, or vocal sound carries meaning. Within a group of dogs, these signals allow individuals to coordinate behavior, establish relationships, and avoid unnecessary conflict. For humans living with dogs, learning to recognize this silent language can dramatically deepen the relationship. What might appear to be random or quirky behavior suddenly reveals itself as communication. A slight head turn may signal uncertainty. A slow blink may indicate relaxation. A play bow invites interaction. Once these signals are understood, it becomes clear that dogs are speaking constantly through movement and expression. Yet these behaviors did not appear suddenly in modern dogs. Many of the signals used by domestic dogs today originated long before dogs lived alongside humans. They evolved within the social world of wolves, where communication was essential for survival within tightly structured packs. To fully understand why dogs possess such sophisticated communication abilities, the story must travel far back in time. Thousands of years ago, before cities, before agriculture, and long before modern dog breeds existed, wolves began approaching human camps on the frozen landscapes of the Ice Age. In those early encounters between humans and wolves, a remarkable partnership began to form, one that would eventually transform both species. Chapter 5. When wolves became dogs. To understand where dogs truly come from, the story must travel far back into the distant past, long before cities, agriculture, or written history existed. More than 20,000 years ago, during the final stages of the Ice Age, the world looked dramatically different from the landscapes we know today. Vast glaciers covered large parts of the northern hemisphere. Much of Europe, Asia, and North America consisted of cold grasslands known as steppe tundra. Across these open landscapes roamed enormous herds of animals such as woolly mammoths, giant bison, horses, and reindeer. These animals supported a complex ecosystem of predators, and among the most successful hunters in this world were wolves. At the same time, humans were also spreading across these harsh environments. Small groups of hunter-gatherers traveled across the same plains and forests, following migrating herds of animals in order to survive. For much of this period, humans and wolves likely existed as competitors. Both species hunted similar prey, relied on cooperative social groups, and possessed high intelligence compared to many other animals. Wolves hunted in organized packs, capable of bringing down animals far larger than themselves. Humans hunted using tools, weapons, and strategy. Yet despite this competition, something unusual began to happen. In certain places and under the right conditions, wolves and humans began forming one of the most remarkable partnerships in the history of life on Earth. The earliest evidence of this relationship comes from archaeology. One of the most famous discoveries occurred in 1914 in a region now part of Germany known as Bonn-Oberkassel. Archaeologists excavating a burial site discovered something extraordinary. The grave contained the remains of two humans, a man and a woman, buried alongside a young dog. The site has been dated to approximately 14,000 years ago, making it one of the oldest known examples of a dog buried intentionally with humans. Careful examination of the dog's skeleton revealed signs that the animal had suffered from a serious disease during its life, likely canine distemper. The condition would have left the animal weak and unable to hunt or survive independently. Yet the dog lived for several weeks after the illness began, suggesting that humans had cared for it during its sickness. The discovery implies that by this time, the relationship between humans and dogs had already evolved beyond simple utility into something resembling companionship. While archaeological discoveries provide physical evidence of early dogs, genetic research has helped scientists trace the deeper evolutionary story. By comparing DNA from modern dogs with that of wolves, researchers have attempted to determine when the two species diverged. Studies published in scientific journals such as Nature and Science have revealed that dogs share a common ancestor with wolves that likely lived between 20,000 and 40,000 years ago. Interestingly, this ancestor was not identical to modern wolves, but belonged to an ancient wolf population that is now extinct. Rather than a single moment when wolves suddenly became dogs, scientists now believe domestication occurred gradually over many generations. One widely supported theory suggests that the earliest step in this process involved wolves approaching human campsites. Hunter-gatherer camps produced scraps of food, discarded bones, and the remains of hunted animals. For opportunistic wolves, these camps represented a reliable source of food that required far less effort than hunting large prey. However, approaching humans was dangerous for most wolves, since people often drove predators away. Only the boldest and least fearful wolves would have risked coming close enough to scavenge. Over time, these less aggressive wolves may have gained an advantage. Individuals that tolerated human presence could access food more easily than wolves that avoided people entirely. Their offspring inherited the same tendency toward reduced fear. Gradually, over many generations, a population of wolves emerged that was more comfortable living near human settlements. These animals were not yet dogs in the modern sense, but they represented the earliest stage of domestication. A fascinating scientific experiment conducted in the 20th century helped illustrate how powerful this process can be. In the 1950s, Russian geneticist Dmitry Belyaev began studying domestication at a research facility in Siberia. Belyaev selected silver foxes from fur farms and began breeding them selectively based solely on one trait: tameness toward humans. The foxes that showed the least fear and aggression were allowed to reproduce, while more aggressive animals were excluded from the breeding program. The results were astonishing. Within only a few generations, the foxes began displaying behaviors strongly associated with domestic dogs. They wagged their tails when humans approached, sought out human attention, and even whined for interaction. Over time, physical changes also appeared. Some foxes developed floppy ears, curled tails, and variations in coat color not seen in wild foxes. These traits are commonly observed in domestic animals and are now understood to be linked to changes in developmental genes associated with reduced aggression. Belyaev's experiment demonstrated how selecting for tameness alone can rapidly transform both behavior and physical appearance. Something similar may have occurred thousands of years earlier with wolves living near human camps. As wolves became more tolerant of humans, a mutually beneficial relationship likely developed. Wolves possessed extraordinary senses of smell and hearing, allowing them to detect approaching animals or threats long before humans noticed them. Early humans may have recognized this advantage and tolerated the presence of these semi-tame wolves around their camps. Wolves, in turn, benefited from access to food scraps and protection from other predators. Eventually, humans may have begun intentionally encouraging certain wolves to remain nearby. Animals that were particularly cooperative or useful may have been fed or protected. Over many generations, this informal partnership evolved into deliberate domestication. Wolves that were friendlier and easier to train became early dogs, gradually diverging from their wild relatives. Archaeological evidence suggests that once domesticated dogs appeared, they spread rapidly alongside human populations. Remains of ancient dogs have been discovered in settlements across Europe, Asia, and the Middle East dating back thousands of years. In many cases, dogs appear in burial sites or artwork, indicating that they held cultural and symbolic importance in addition to practical value. In some ancient societies, dogs were buried with grave goods or alongside their owners, suggesting that people viewed them as companions rather than simply working animals. Dogs quickly became valuable partners in hunting. Their sense of smell allowed them to track animals across large distances, while their speed and endurance helped pursue prey that might otherwise escape. In regions such as Siberia and the Arctic, dogs played a crucial role in helping humans locate animals across vast, snowy landscapes. In the Middle East and parts of Africa, dogs assisted hunters in chasing gazelles and other fast-moving animals. This cooperation allowed humans to hunt more efficiently, while giving dogs access to reliable food. The domestication process also gradually transformed the physical appearance of dogs. Compared with wolves, domestic dogs developed shorter snouts, smaller teeth, and a wider range of coat colors and patterns. These changes are believed to result partly from genetic shifts associated with tameness. When aggression decreases during domestication, developmental pathways in the body change in ways that affect multiple traits simultaneously. This phenomenon explains why many domesticated animals share certain physical features such as floppy ears, curled tails, and more varied coloration. By the time humans began transitioning from hunter-gatherer societies to agricultural communities roughly 10,000 years ago, dogs had already spread across much of the world. As people migrated across continents, dogs traveled with them. They accompanied humans into Europe, across Asia, into Africa, and eventually across the land bridge into the Americas. Wherever human societies formed, dogs soon appeared as well. This partnership between humans and dogs became one of the most significant relationships in human history. Long before humans domesticated horses, cattle, or sheep, dogs had already become companions, guardians, and hunting partners. In many ways, dogs helped humans survive in environments that would have been far more challenging without their assistance. At the same time, humans provided dogs with shelter, food, and protection that allowed them to thrive across nearly every environment on Earth. Yet domestication did more than simply change how dogs looked or behaved. Over thousands of years living alongside humans, dogs also experienced profound changes inside their brains. Natural selection favored animals that could interpret human signals, cooperate with people, and adapt to human social environments. These changes gradually shaped the canine mind into something uniquely suited for life with humans. The next chapter turns to this transformation in greater detail. Modern neuroscience has begun revealing how domestication altered the structure and function of the dog brain. After thousands of years evolving alongside humans, dogs developed neural systems that allow them to process human voices, recognize our emotions, and form deep social bonds with us in ways that few other animals can match. Chapter 6. Inside the Dog Brain. For thousands of years, humans have lived alongside dogs, observing their loyalty, intelligence, and emotional sensitivity without fully understanding what might be happening inside their minds. For most of history, the inner workings of the canine brain remained a mystery. Scientists could study behavior, but directly observing brain activity in animals posed enormous challenges. Unlike humans, animals cannot easily be asked to remain perfectly still inside complex medical equipment. As a result, much of what researchers believed about animal cognition was based on indirect observation rather than direct neurological evidence. Over the past 2 decades, however, advances in neuroscience and imaging technology have begun revealing what actually occurs inside the canine brain, offering remarkable insights into why dogs appear so uniquely attuned to human behavior. One of the most groundbreaking research programs in canine neuroscience emerged in Hungary at Eötvös Loránd University. There, a team of researchers led by neuroscientist Attila Andix developed an innovative method for studying the brains of awake dogs using functional magnetic resonance imaging, commonly known as fMRI. The challenge was considerable. MRI machines require subjects to remain completely still inside a narrow scanning tube while loud mechanical noises occur during the imaging process. Sedating animals would make it impossible to observe natural brain responses, so the researchers needed dogs that could voluntarily remain motionless during the scans. To accomplish this, the team trained dogs through positive reinforcement techniques to calmly lie inside the scanner while wearing protective ear coverings. The dogs were gradually accustomed to the sounds and environment of the machine until they were comfortable enough to remain still for extended periods. This achievement represented a major breakthrough in animal neuroscience because it allowed scientists to observe brain activity in dogs without interfering with their natural cognitive processes. When the first scans were completed, the results revealed something extraordinary. Dogs possess brain regions that respond specifically to vocal sounds, including the human voice. When researchers played recordings of human speech, certain areas of the canine brain became active in patterns strikingly similar to those seen in human brains when people hear voices. This discovery suggested that dogs do not simply hear sounds as meaningless noise. Instead, their brains appear specially equipped to recognize and process vocal signals from humans. Even more fascinating was how dogs responded to emotional tone. When researchers played recordings of their owners speaking in a happy or praising voice, reward centers within the dog's brains became active. These regions are associated with positive emotional experiences, similar to how human brains respond to praise or affection. When the same words were spoken in a neutral tone, the level of brain activation decreased significantly. This indicates that dogs are highly sensitive not just to the words humans speak, but also to the emotional tone embedded within those words. These findings help explain something many dog owners notice instinctively. A dog often responds more strongly to the emotional tone of a sentence than to the actual vocabulary used. A cheerful voice expressing approval may excite a dog even if the specific words are unfamiliar, while a harsh tone may cause the dog to become cautious regardless of the content of the speech. The canine brain appears to prioritize emotional information carried in sound, allowing dogs to interpret human intentions quickly and accurately. Another fascinating discovery involves how dogs recognize human faces. Although dogs rely heavily on smell, vision also plays an important role in their social perception. Researchers at Kyoto University conducted experiments showing that dogs can distinguish between familiar and unfamiliar human faces using visual information alone. When dogs were shown images of their owners and strangers, they displayed noticeably different patterns of attention and engagement. In many cases, dogs focused longer on images of their owners and showed signs of excitement or curiosity. This suggests that dogs maintain visual memories of specific individuals and are capable of recognizing people they know. Combined with their powerful sense of smell and sensitivity to voice, this visual recognition contributes to a multi-layered system through which dogs identify and interpret the humans around them. Language processing represents another intriguing aspect of canine cognition. Although dogs do not understand grammar in the same way humans do, research suggests they can associate specific words with objects, actions, or experiences. Studies examining canine brain activity have shown that dogs respond differently when they hear familiar words compared to unfamiliar sounds. When a dog hears a word it has learned through training, such as the name of a toy or a command, distinct neural patterns appear in regions associated with memory and recognition. These findings suggest that dogs store certain words in memory and retrieve their meaning when they hear them spoken. The process may not involve complex linguistic structure, but it demonstrates that dogs can develop a vocabulary linking sounds to specific outcomes. For animals living closely with humans, this ability provides a powerful advantage, allowing them to understand commands, recognize names, and anticipate activities such as walks or meals. Beyond perception and learning, dogs also appear capable of experiencing a range of emotions that resemble those found in humans. Brain imaging studies indicate that dogs experience joy, anticipation, and social attachment. When dogs interact with their owners through play, petting, or praise, reward centers within the brain become highly active. These neural responses are similar to those observed in humans during positive social interactions. Some researchers believe dogs may also display early forms of empathy. Experiments observing dogs reacting to human distress have shown that many dogs approach individuals who appear to be crying or upset. While scientists continue debating whether dogs fully understand human emotions or simply respond to behavioral cues, the neurological evidence suggests that dogs are strongly motivated by social connection. Their brains appear wired to prioritize relationships with humans and other dogs. Another area where canine cognition closely parallels human experience involves sleep and dreaming. Like humans, dogs experience multiple stages of sleep, including a phase known as rapid eye movement or REM sleep. During REM sleep, the brain becomes highly active, and this stage is closely associated with dreaming. Observers often noticed dogs twitching their paws, wagging their tails slightly, or making small vocalizations while sleeping. Scientists believe these movements reflect the brain replaying experiences from the dog's waking life. Similar processes occur in humans, where dreams often involve fragments of daily experiences being reorganized in memory. The presence of REM sleep in dogs suggests that their brains process and store memories in ways that resemble human memory consolidation. Although we cannot know exactly what dogs dream about, it is possible that they mentally revisit events such as playing, exploring, or interacting with their owners. Memory itself plays a crucial role in how dogs navigate their environment. Researchers working with the Family Dog Project have conducted experiments demonstrating that dogs can remember actions performed by humans and later imitate them. In these studies, dogs were trained using a method called "do as I do," in which they watched a person perform a specific action and were later asked to repeat it. The results showed that dogs could recall and replicate actions after a delay, indicating the presence of episodic-like memory. Episodic memory refers to the ability to remember specific events from the past rather than simply storing habits or learned behaviors. Although canine memory may not be identical to human memory, the experiments suggest that dogs can remember particular experiences and use those memories to guide future behavior. One of the most important biological mechanisms underlying the human-dog relationship involves the hormone oxytocin. Often referred to as the bonding hormone, oxytocin plays a central role in forming emotional attachments. In humans, oxytocin levels increase during positive social interactions, particularly between parents and infants. Remarkably, similar hormonal changes occur during interactions between dogs and their owners. When dogs and humans engage in activities such as petting, playing, or making eye contact, oxytocin levels rise in both species. This mutual hormonal response reinforces emotional bonding and strengthens the relationship between dog and owner. Over time, repeated interactions create a powerful feedback loop in which positive experiences increase oxytocin levels, encouraging further social connection. Domestication may also have influenced how dogs respond to stress. Compared with wolves, dogs generally display reduced fear responses when interacting with humans. Wolves raised by humans can form social bonds, but they often remain more cautious and reactive to unfamiliar situations. Dogs, by contrast, have evolved greater tolerance for human presence and environmental variability. These differences likely reflect thousands of years of selective pressures favoring animals that could adapt to human environments. Wolves that were excessively fearful or aggressive toward humans were less likely to remain near human settlements. Over generations, natural and artificial selection favored individuals with calmer temperaments and stronger social responsiveness to people. The cumulative effect of these neurological and behavioral changes is profound. Modern dogs possess brains that appear uniquely adapted for cooperation with humans. Their neural systems are highly sensitive to human voices, facial expressions, emotional tones, and social cues. They form deep attachments reinforced by hormonal processes and learn from observing human actions. When scientists examine the canine brain today, they see evidence of a long evolutionary partnership. Dogs did not simply learn to live with humans. Their minds evolved in response to thousands of years of shared experience. The neural architecture of the dog brain reflects a species that has adapted not just to survive alongside humans, but to understand us in ways few other animals can. Yet while the canine brain provides remarkable insight into how dogs interpret human behavior, another part of the dog's body grants access to an entirely different dimension of perception. Beyond the brain lies an organ that allows dogs to experience the world in ways humans can barely imagine. The next chapter explores the extraordinary power of a dog's nose, an organ so sensitive that it can detect scents at concentrations far beyond the limits of human perception. Chapter 7. The superpower in a dog's nose. For thousands of years, humans have known that dogs possess an extraordinary ability to follow scent trails across landscapes that appear empty to human senses. Long before laboratories and scientific instruments existed, hunters, shepherds, and trackers depended on dogs to locate animals, find lost people, and detect hidden threats. Ancient artwork from civilizations such as Egypt shows dogs assisting hunters in tracking animals across desert terrain. In medieval Europe, nobles relied on specially bred scent hounds capable of following the trail of deer or boar through dense forests. Although these abilities were widely recognized, the biological explanation behind them remained mysterious for centuries. Only in the late 20th and early 21st centuries did scientists begin to fully understand the remarkable mechanisms inside a dog's nose that make these feats possible. The first clue lies in the sheer number of scent receptors located inside the canine nose. Humans possess approximately 6 million olfactory receptors, which are the specialized sensory cells responsible for detecting odor molecules. Dogs, by comparison, possess vastly more. Depending on the breed, dogs may have anywhere from 100 million to more than 300 million olfactory receptors. Breeds specifically developed for scent tracking often possess the highest numbers. Among the most famous of these breeds is the bloodhound, whose long ears and wrinkled facial skin help funnel scent particles toward the nose while tracking. The bloodhound's extraordinary scent detection ability has made it legendary among trackers for centuries. The difference between human and canine smell does not stop with receptor numbers. The canine brain also devotes far more processing power to interpreting scent information. When scientists compare the brains of humans and dogs, they find that the region responsible for analyzing smell is proportionally much larger in dogs. Relative to overall brain size, the olfactory bulb in dogs is estimated to be roughly 40 times more developed than in humans. This means that dogs not only detect far more odor molecules, but also analyze them with a much more powerful neural processing system. The physical design of the canine nose also contributes significantly to this remarkable ability. When humans inhale, air travels through a relatively simple pathway used both for breathing and scent detection. In dogs, however, airflow is separated into two distinct channels. One channel carries air directly to the lungs for breathing, while another directs odor molecules into a specialized region called the olfactory recess. This chamber is lined with complex folds of tissue that trap scent particles and allow the receptors to analyze them in detail. Even more impressive is the way dogs sniff. When a dog rapidly inhales through the nose, it creates swirling air currents that trap odor molecules inside the nasal cavity. At the same time, when the dog exhales, air exits through slits along the sides of the nose rather than straight out the nostrils. This design prevents outgoing air from disrupting the incoming scent. As a result, dogs can continue sampling odor molecules even while exhaling. When dogs appear to sniff the ground rapidly, they're essentially taking dozens of scent samples every second, building a detailed chemical map of their surroundings. In addition to the primary olfactory system, dogs possess another sensory structure that enhances their ability to detect chemical signals. Inside the nasal cavity lies a specialized organ known as the vomeronasal organ, sometimes referred to as Jacobson's organ. This structure is particularly sensitive to pheromones and other chemical signals produced by animals. Through this system, dogs can gather detailed information about other animals, including reproductive status, emotional condition, and even certain health indicators. This ability helps explain why dogs spend so much time sniffing when they meet other animals, as they are collecting an enormous amount of chemical information invisible to humans. These biological features allow dogs to perform feats of scent tracking that seem almost impossible. Every time a person walks through an environment, the body leaves behind microscopic traces of scent. Humans constantly shed tiny particles of skin known as skin rafts. Each person sheds thousands of these microscopic cells every minute, and each cell carries a unique scent signature produced by bacteria and body chemistry. As a person moves across the ground, these cells fall onto the surface and become trapped in soil, grass, or other materials. To human senses, this trail is completely invisible. To a dog, however, it forms a clear chemical path. A trained tracking dog can follow the scent left behind by these microscopic particles even after hours or days have passed. Environmental conditions such as wind, temperature, and humidity can affect how long a scent trail remains detectable, but under favorable conditions, dogs have demonstrated the ability to track individuals across considerable distances. Among the most famous examples of scent tracking are those involving bloodhounds used in criminal investigations. For centuries, law enforcement agencies have relied on these dogs to follow the trail of suspects who have fled a crime scene. In some jurisdictions, the accuracy of bloodhound tracking has even been recognized as admissible evidence in court. One often cited case occurred in the early 20th century in Kentucky, where a bloodhound followed the scent trail of a suspect for more than 30 miles over the course of several days. The dog ultimately led investigators directly to the individual responsible for the crime. Dogs also perform crucial roles in search and rescue missions following natural disasters or accidents. When buildings collapse during earthquakes or explosions, survivors may become trapped beneath layers of rubble. Human rescuers often struggle to locate victims quickly in these chaotic environments. Specially trained search and rescue dogs can navigate unstable debris fields while relying on their noses to detect the scent of trapped individuals. Because scent particles travel through cracks and air pockets, dogs can sometimes locate people buried deep beneath rubble. One of the most dramatic demonstrations of this ability occurred following the September 11th attacks in New York City. After the collapse of the World Trade Center towers, hundreds of search and rescue dogs were deployed alongside emergency responders. These dogs worked tirelessly across the massive debris field, locating survivors and later helping identify human remains. Their ability to detect scent under such extreme conditions proved invaluable to rescue teams. Law enforcement agencies around the world also depend heavily on dogs trained for scent detection. Police canine units train dogs to detect a wide range of substances, including narcotics, explosives, firearms, and even hidden electronic devices. Certain electronic components release chemical compounds that dogs can detect, allowing trained dogs to locate hidden digital storage devices such as USB drives or hard drives during criminal investigations. This ability has proven particularly useful in cases involving digital evidence that might otherwise remain concealed. Beyond law enforcement and rescue work, dogs are increasingly being used in scientific research and conservation. In recent years, researchers have trained what are known as conservation detection dogs to locate the droppings or scat of rare or endangered animals in wilderness areas. By analyzing these samples, scientists can learn valuable information about species population size, diet, and health without disturbing the animals themselves. In regions such as the Pacific Northwest of North America, conservation dogs have been trained to locate the scat of wolves and other elusive wildlife across large forested landscapes. Similar programs have trained dogs to detect the droppings of marine animals such as orcas by sampling scent from boats traveling across coastal waters. Because dogs can cover large areas quickly and locate samples that humans might never notice, they have become powerful tools in modern wildlife research. Medical research has also begun exploring the limits of canine scent detection. Scientists have discovered that diseases can alter the chemical compounds released by the human body. As mentioned earlier in this documentary, dogs have been trained to detect certain cancers, bacterial infections, and viral diseases through scent alone. Research programs are currently exploring whether dogs can detect illnesses such as malaria or tuberculosis by analyzing subtle changes in body odor. Perhaps the most remarkable aspect of the canine nose is its flexibility. Dogs can be trained to recognize specific scents and ignore thousands of other odors in the environment. Unlike many mechanical senses, which struggle to isolate individual chemicals from complex mixtures, dogs can identify a target's scent even when it is surrounded by many other competing odors. Their brains are capable of separating scent signals in ways that current technology still finds difficult to replicate. As scientists continue studying canine scent detection, one realization becomes increasingly clear. Dogs experience the world in a sensory landscape dramatically different from our own. Humans rely primarily on vision to understand our surroundings. We navigate using what we see. Dogs, however, inhabit a world defined by smell. Every surface, every gust of wind, and every living creature leaves behind a trail of chemical information that dogs can perceive instantly. For a dog, the ground beneath its paws is not simply dirt or grass, but a complex map of scents left behind by animals, humans, and environmental changes. A passing breeze carries detailed information about distant locations. A single footprint may reveal the identity of the individual who left it hours earlier. The world, from a dog's perspective, is filled with invisible stories written in scent. Yet despite this extraordinary sensory power, not all dogs display the same abilities. Some breeds appear especially skilled at learning tasks, solving problems, and cooperating with humans in complex environments. This observation leads to another fascinating question. If dogs share the same biological tools, why do some dogs seem remarkably intelligent while others appear less capable of certain tasks? The answer lies partly in the history of selective breeding and the development of specialized dog breeds. Over generations, humans have shaped different types of dogs for specific roles such as herding, hunting, guarding, or companionship. These roles influenced the development of different forms of intelligence within the canine world. The next chapter explores this fascinating topic by examining how scientists measure canine intelligence and why certain breeds appear exceptionally capable when working alongside humans. Chapter 8. The most intelligent dogs. For as long as humans have lived alongside dogs, people have noticed that some dogs appear to learn faster, solve problems more easily, and respond to commands with remarkable precision. Shepherds working in remote pastures often observed that certain dogs could manage an entire flock almost intuitively, responding to whistles or gestures from hundreds of yards away. Hunters noticed that some dogs adapted quickly to complex situations in the field, navigating forests, rivers, and changing terrain while tracking animals. Even within ordinary households, people often remark that some dogs seem almost startlingly perceptive, anticipating routines and learning commands after only a few repetitions. These observations eventually led scientists to ask a question that had long fascinated dog owners. Are some dog breeds truly more intelligent than others? The scientific investigation of canine intelligence began to take shape during the 20th century as psychologists began studying how animals learn, remember, and solve problems. Researchers recognized that intelligence in animals could not simply be measured through human standards, such as language or abstract reasoning. Instead, they began designing experiments that examined learning speed, memory, problem-solving ability, and the capacity to respond to human instructions. Among the most influential figures in this field was Stanley Coren, a professor at University of British Columbia who helped popularize the modern understanding of canine intelligence. In the 1990s, Coren conducted an extensive survey involving hundreds of professional dog trainers across North America. These trainers worked with dogs in obedience competitions, service training programs, and working roles, giving them direct experience, observing how quickly different breeds learned commands and responded to training. Coren compiled their responses to create a ranking of dog breeds based on what he described as working and obedience intelligence. This ranking measured how many repetitions a breed typically required to learn a new command and how consistently the dog responded to that command once trained. Among the breeds that consistently ranked near the top of Corin's list was the Border Collie, widely considered one of the most intelligent dog breeds in the world. Border Collies originated in the rugged borderlands between Scotland and England, where shepherds relied on them to manage large flocks of sheep across steep hills and wide-open pastures. Herding is an extraordinarily complex task that requires dogs to make rapid decisions while maintaining constant awareness of both the livestock and the human handler. Border Collies must respond instantly to whistles or hand signals, sometimes from hundreds of meters away, while simultaneously controlling the movement of animals that may scatter or panic. Over generations, these demands shaped a breed with exceptional focus, memory, and problem-solving ability. Border Collies often display an intense concentration known as the eye, a behavior in which the dog locks its gaze onto livestock and carefully controls their movement through subtle shifts in posture. This combination of intelligence, instinct, and responsiveness has made the Border Collie one of the most celebrated working dogs in agricultural communities around the world. Another breed frequently recognized for its intelligence is the Poodle. Although many people today associate poodles primarily with show competitions or companion roles, the breed originally developed as a working dog. The Poodle's name comes from the German word Pudel, meaning to splash in water, reflecting the breed's origins as a water retriever used by hunters. Poodles were trained to retrieve waterfowl from lakes and rivers, a task that required strong swimming ability, keen observation, and the capacity to follow complex commands during hunting expeditions. Poodles excel in learning new behaviors and adapting to unfamiliar environments, traits that have contributed to their success in obedience competitions and service work. Their intelligence, combined with their agility and trainability, allows them to perform a wide range of tasks. In modern times, poodles have served as guide dogs, therapy animals, and even search and rescue dogs in certain contexts. The German Shepherd provides another striking example of canine intelligence combined with versatility. This breed was developed in Germany during the late 19th century by a cavalry officer named Max von Stephanitz, who sought to create the ideal working dog capable of herding livestock while also performing protective duties. German Shepherds quickly gained recognition for their trainability, loyalty, and ability to remain focused under stressful conditions. Today, German Shepherds are widely used in police and military roles around the world. Their intelligence allows them to learn complex tasks such as tracking suspects, detecting explosives, and assisting in search and rescue missions. Their ability to maintain discipline while performing demanding work has made them one of the most respected working breeds in law enforcement and security operations. Another highly trainable breed is the Golden Retriever, a dog originally developed in Scotland during the 19th century by a landowner named Dudley Marjoribanks. Golden Retrievers were bred to retrieve waterfowl during hunting expeditions, often working in cold lakes and marshes. Their task required them to remember where birds had fallen, swim long distances to retrieve them, and return them gently to their handlers without damaging the game. The breed's intelligence, combined with its calm and friendly temperament, has made Golden Retrievers especially valuable in modern service roles. They are widely used as guide dogs for individuals with visual impairments, assistance dogs for people with physical disabilities, and therapy dogs in hospitals and rehabilitation centers. Their ability to learn commands quickly and respond reliably in complex environments reflects a high level of working intelligence. Another breed often recognized for its intelligence and alertness is the Doberman Pinscher. Developed in Germany in the late 19th century by a tax collector named Karl Friedrich Louis Dobermann, the Doberman Pinscher was bred to serve as a protective companion. Dobermans are known for their speed, agility, and sharp awareness of their surroundings. Their intelligence allows them to learn advanced obedience tasks and protective behaviors, making them valuable in security roles and competitive training disciplines. Despite the popularity of breed rankings, scientists emphasize that intelligence in dogs cannot be reduced to a single measure. Researchers often describe several different categories of canine intelligence, each reflecting different cognitive abilities. Instinctive intelligence refers to the skills dogs inherit through selective breeding. For example, herding breeds possess instincts that allow them to control livestock, while retrieving breeds are naturally inclined to carry objects gently in their mouths. Adaptive intelligence refers to a dog's ability to solve problems independently without direct human guidance. This form of intelligence becomes apparent when dogs encounter unfamiliar challenges, such as figuring out how to open a container, holding food, or navigating obstacles in their environment. Dogs demonstrating strong adaptive intelligence can learn from experience and adjust their behavior based on trial and error. Working intelligence, sometimes called obedience intelligence, measures how quickly a dog learns commands from humans and how reliably the dog performs those commands. This is the category most often measured in obedience competitions and training evaluations. Dogs with strong working intelligence typically learn new commands after relatively few repetitions and respond consistently to their handler's instructions. Research conducted at the Duke Canine Cognition Center has explored how dogs solve complex problems involving hidden food rewards or puzzle devices. In these experiments, dogs must manipulate objects such as sliding panels, levers, or containers in order to access food hidden inside. Some dogs quickly learn to experiment with different strategies using trial and error until they discover the correct solution. These studies reveal that many dogs possess impressive reasoning abilities, particularly when motivated by rewards. However, the results also vary widely among individual dogs, highlighting the role of personality, training history, and environmental experience in shaping canine cognition. Perhaps one of the most extraordinary examples of canine learning involves dogs capable of recognizing large vocabularies of words. Earlier in this documentary, we discussed the famous border collie named Chaser, who learned the names of more than 1,000 individual objects during experiments conducted by psychologist John Pilley. Chaser's ability to retrieve specific toys when asked demonstrated that dogs can associate spoken words with particular items in memory. Other dogs have demonstrated the ability to infer the meaning of new words by process of elimination. When presented with several objects whose names they already know, alongside a new object with an unfamiliar name, some dogs correctly choose the new object when hearing the unfamiliar word. This ability suggests that dogs may use a simple form of reasoning similar to the way children learn new vocabulary. However, one important misconception about canine intelligence deserves attention. Breeds that rank lower in obedience-based intelligence are not necessarily less intelligent overall. Some breeds were developed for tasks requiring independence rather than constant human guidance. The Afghan hound, for example, was bred to chase prey across rugged terrain with minimal instruction from humans. Similarly, the Basenji was developed for independent hunting in dense forests. Dogs bred for these roles may appear stubborn or uninterested in following commands, but their behavior reflects their historical function rather than a lack of intelligence. Independent hunting dogs often rely on their own judgment rather than waiting for human instructions, which can make them seem less obedient in structured training environments. Ultimately, the wide range of canine intelligence reflects the diverse roles dogs have played throughout human history. Over thousands of years, humans selectively bred dogs for tasks requiring different cognitive abilities. Some dogs excel at interpreting human commands. Others specialize in tracking scent trails, and still others demonstrate remarkable independence in solving problems on their own. As we step back and examine this diversity, a deeper realization emerges. Even the most intelligent modern dogs still carry behaviors inherited from their wild ancestors. Beneath the training, companionship, and domestication lies a foundation shaped by thousands of years of evolution alongside wolves. The next chapter explores this connection to the past by examining the ancient instincts that still appear in everyday canine behavior. From circling before lying down to howling at distant sounds, many of the habits dogs display today can be traced back to the survival strategies of their wolf ancestors. Chapter 9. The Wolf Inside Every Dog. At first glance, modern dogs appear far removed from the wild predators that once roamed the Ice Age landscapes alongside early humans. Today, dogs sleep on couches, ride in cars, and share homes with families across the world. Many breeds have soft fur, rounded faces, and friendly expressions that seem far removed from the lean, powerful form of a wolf. Yet beneath this domesticated appearance lies an ancient inheritance. Every dog alive today still carries the behavioral blueprint of its ancestors. Although thousands of years of domestication have shaped the dog into a human companion, many of the instincts that helped wolves survive in the wild remain embedded deep within canine behavior. These ancestral instincts appear in everyday actions that dog owners observe constantly but rarely question. A dog may suddenly circle several times before lying down to sleep, bury a favorite toy in the backyard, or chase a moving object with surprising intensity. To the casual observer, these behaviors may appear playful or random. But when scientists examine them closely, they reveal traces of survival strategies that originated thousands of years ago in the lives of wolves. One of the most common examples occurs whenever a dog prepares to rest. Many dogs circle repeatedly before lying down, sometimes scratching or pawing at the ground as they settle. This behavior appears across nearly all dog breeds, from small companion dogs to large working animals. Researchers believe this instinct originated from wolves preparing sleeping areas in the wild. When wolves stop to rest in natural environments such as grasslands or forests, the ground may contain tall vegetation, hidden insects, or even small animals. By circling and trampling the area with their paws, wolves flatten the vegetation and create a more comfortable sleeping surface. At the same time, this movement helps check for potential threats hidden in the ground. In snowy environments, circling may also help wolves pack down snow to form a more insulated resting place. By compressing the snow beneath their bodies, wolves reduce heat loss during cold nights. Even though domestic dogs now sleep in comfortable homes, the instinct to prepare a resting site remains deeply ingrained in their behavior. Another fascinating behavior inherited from wolves involves the tendency to bury food or other valuable objects. Many dog owners have watched their pets carry bones, treats, or toys into a yard, or even hide them beneath blankets or cushions inside the house. After carefully digging or arranging the hiding place, the dog may leave the object buried for later use. This behavior reflects a survival strategy known as caching, which is common among wild animals that experience periods of feast and famine. Wolves sometimes encounter situations where food is abundant, such as after a successful hunt of a large animal. Because a wolf cannot consume an entire carcass at once, it may hide portions of the food for later consumption. By burying excess food beneath soil, leaves, or snow, the animal reduces the chance that scavengers will find it. Domestic dogs retain this instinct, even though food is readily available in modern homes. The urge to store valuable resources for later remains part of their behavioral heritage. Another strong connection to canine ancestry appears in the haunting sound of a howl. Wolves rely heavily on howling as a form of long-distance communication. A wolf's howl can travel several miles across open landscapes, allowing members of a pack to locate each other or coordinate movement across large territories. Howling also serves as a territorial signal, warning other wolves that an area is already occupied. Domestic dogs rarely rely on howling as their primary vocal communication because they have adapted to living in close proximity to humans. Barking has become a more common form of vocalization in domestic dogs, possibly because barking is more effective for communicating with people at short distances. Nevertheless, the instinct to howl remains present in many dogs. Some dogs begin howling when they hear sirens, musical instruments, or high-pitched electronic sounds. These noises may resemble the long, sustained tones of wolf howls, triggering an ancient vocal response that echoes through the dog's evolutionary past. Territorial behavior also reflects the legacy of wolves. In the wild, wolf packs defend territories that may cover dozens or even hundreds of square miles. These territories contain vital resources such as prey animals, water sources, and safe den sites. Wolves mark their territory through scent markings and vocal signals, warning other packs to stay away. Domestic dogs often display similar territorial instincts, although the scale is dramatically smaller. Many dogs bark when strangers approach their homes or when unfamiliar animals enter the yard. Even indoor dogs may react strongly to sounds or movement outside windows and doors. While these reactions may sometimes appear excessive in modern environments, they reflect a protective instinct that once helped wolves defend their territory and resources. Chasing behavior offers another vivid reminder of canine ancestry. Wolves are predators specialized for pursuing moving prey across open landscapes. Their bodies evolved for endurance running, allowing them to chase animals such as deer, elk, or bison over long distances. This predatory drive remains present in many domestic dogs, particularly those bred for hunting. When a dog suddenly races after a running squirrel, bicycle, or thrown ball, it is expressing an instinct rooted in ancient hunting behavior. Certain breeds show especially strong chasing instincts because humans selectively bred them for hunting tasks. Sighthounds such as the greyhound and whippet were developed to pursue fast-moving animals across open terrain. These breeds possess incredible speed and are highly sensitive to movement, making them particularly prone to chasing objects that trigger their prey drive. Play behavior among dogs also reflects ancient pack dynamics. When dogs engage in play fighting, chasing games, or wrestling with one another, they are not simply entertaining themselves. These activities mirror behaviors that young wolves use to practice essential survival skills. Wolf pups spend large portions of their early lives play fighting with siblings, developing coordination, strength, and social awareness. Through play, they learn how to bite gently, control their movements, and understand social boundaries within the pack. Domestic dogs display many of the same playful behaviors. A dog that lowers its front legs while raising its hind quarters into the air, a posture known as a play bow, is inviting another dog or human to engage in playful interaction. This gesture signals that the following actions are intended as play rather than aggression. Even during rough play, dogs frequently pause and reset their behavior to ensure that the interaction remains friendly. Another intriguing behavior often observed by dog owners is the head tilt. When a dog tilts its head while listening to a human voice or unfamiliar sound, it can appear almost as if the animal is expressing curiosity or confusion. Scientists believe this behavior may serve several practical purposes. By tilting the head, a dog may adjust the position of its ears in order to better locate the direction of a sound. Because dogs possess highly sensitive hearing, small adjustments in ear orientation can improve their ability to determine where a sound originates. Some researchers also suggest that head tilting may help dogs better interpret human facial expressions. Dogs with longer snouts may partially block their view of a person's mouth or facial movements when looking straight ahead. Tilting the head slightly could allow the dog to observe subtle facial cues that help interpret human communication. Social hierarchy represents another behavior inherited from wolves. In wild wolf packs, social structure plays a critical role in maintaining order and cooperation. packs typically contain dominant individuals responsible for leading hunts and making decisions about movement and territory. Other members of the pack follow established roles that help prevent conflict and ensure survival. Domestic dogs often live in human households rather than structured packs, but elements of social hierarchy can still appear in interactions between dogs. When multiple dogs share a living space, they may establish informal rankings that determine access to food, resting areas, or preferred sleeping spots. These hierarchies are usually maintained through subtle body language rather than aggressive confrontation. Even the way dogs greet each other reflects their evolutionary past. When two unfamiliar dogs meet, they often engage in a ritual of sniffing each other's hindquarters. While this behavior may appear strange or humorous to human observers, it serves an important communication function in the canine world. Dogs possess scent glands located near the base of the tail that release chemical signals containing detailed information about the individual. By sniffing these scent glands, dogs can quickly gather information about another dog's identity, sex, health status, and emotional condition. In essence, the greeting ritual functions as a chemical exchange of personal information, allowing dogs to recognize and assess one another within seconds. Understanding these behaviors reveals an important truth about modern dogs. Although domestication has dramatically reshaped their lives, dogs have not lost the instincts that once allowed wolves to survive in the wild. Beneath their friendly demeanor and close relationship with humans lies a genetic heritage forged over thousands of years of evolution. Dogs occupy a unique position in the natural world. They are descendants of powerful predators capable of surviving harsh wilderness environments. Yet they have also become humanity's closest animal companions. This combination of wild instinct and social connection creates a relationship unlike any other between humans and animals. As the story moves forward, another aspect of this relationship becomes increasingly clear. Beyond shared history and inherited instincts, dogs and humans have developed a deep emotional bond that continues to shape both species. The next chapter explores how this extraordinary connection formed and why dogs have become one of the most trusted and beloved companions in human history. Chapter 10. The bond no other animal shares. Long before modern science attempted to measure the emotional lives of animals, humans already sensed that the relationship between people and dogs was unlike any other connection between species. Across thousands of years of recorded history, cultures around the world have described dogs not simply as working animals, but as loyal companions who seemed capable of devotion, empathy, and emotional understanding. Ancient writings, folklore, and mythology repeatedly tell stories of dogs remaining faithful to their owners long after logic would suggest they should move on. While these stories were once considered romantic exaggerations, modern scientific research increasingly suggests that the emotional connection between humans and dogs may indeed be extraordinary in the animal kingdom. One of the earliest and most famous examples of this idea appears in ancient Greek literature. In the epic poem, The Odyssey, the hero Odysseus returns home after 20 years of war and wandering. Disguised and unrecognizable to nearly everyone in his household, Odysseus quietly enters his home. Yet one creature recognizes him instantly: his aging dog, Argos. According to the story, Argos had waited faithfully for his master throughout 2 decades of absence. Upon finally seeing Odysseus again, the old dog recognizes him, wags his tail, and then dies peacefully at his master's feet. Although the story is mythological, it reflects a deep cultural belief that dogs possess a loyalty and emotional connection to humans that transcends ordinary animal behavior. For centuries, such stories remained part of folklore rather than scientific investigation. Only in recent decades have researchers begun examining the biological foundations of the human-dog relationship. One of the most important discoveries involves a hormone known as oxytocin, often referred to as the bonding hormone. In humans, oxytocin plays a crucial role in social attachment, particularly between parents and infants. When parents hold or gaze at their babies, oxytocin levels rise in both individuals, reinforcing emotional bonds and nurturing behavior. In 2015, researchers led by Miho Nagasawa at Azabu University conducted an experiment designed to explore whether this same hormonal system might operate between dogs and humans. During this study, dogs and their owners spent time interacting naturally while researchers measured oxytocin levels in both species. The results revealed something remarkable. When dogs and humans made prolonged eye contact, oxytocin levels increased significantly in both the dog and the human. The longer the gaze lasted, the greater the hormonal increase. This finding suggested that the human-dog relationship may activate the same biological bonding mechanisms that exist between human parents and children. In other words, the emotional connection people feel toward their dogs may not simply be psychological or cultural. It may be rooted in shared biological processes that evolved over thousands of years of companionship. Behavioral studies provide further evidence of this deep attachment. Researchers at University of Vienna conducted experiments designed to test how dogs behave in unfamiliar or potentially stressful environments. In these studies, dogs were placed in new surroundings with either their owners or unfamiliar people present. The results consistently showed that dogs displayed lower stress levels when their owners were nearby. Heart rate, body language, and exploratory behavior all suggested that dogs use their owners as a form of emotional security. This pattern closely resembles the secure base effect observed in human children. In developmental psychology, infants often use the presence of a parent as a source of safety when exploring unfamiliar environments. When the parent is nearby, children feel more confident exploring new spaces because they know they can return to a trusted caregiver if needed. Researchers observed a remarkably similar pattern in dogs, suggesting that dogs may perceive their human companions in ways comparable to how children perceive caregivers. Stories of canine loyalty also appear frequently in real historical records. One of the most famous examples occurred in early 20th century Japan. A dog named Hachiko belonged to a professor named Hidesaburo Ueno at University of Tokyo. Each day, Hachiko accompanied his owner to the train station in the morning and returned in the afternoon to greet him when he came home from work. In 1925, Professor Ueno died suddenly while at the university. Despite his owner's death, Hachiko continued returning to Shibuya Station every afternoon, waiting for the train that would never bring his owner home. For nearly 10 years, the dog returned to the same location each day, patiently waiting. Commuters and station workers began feeding and caring for the dog, and his story eventually became widely known across Japan. Today, a bronze statue of Hachiko stands outside Shibuya Station, commemorating what many consider one of the most powerful examples of canine loyalty ever recorded. Scientific research suggests that such loyalty may be connected to the deep social bonds dogs form with their human families. Veterinarians and animal behaviorists have documented numerous cases in which dogs appear to grieve after the loss of a human companion. Dogs in mourning sometimes display behavioral changes such as reduced appetite, increased sleep, withdrawal from social interaction, or searching behavior in areas where the lost individual once appeared. Researchers at University of Milan conducted studies examining behavioral changes in dogs following the death of a companion animal within the same household. Many dogs displayed prolonged signs of distress and behavioral changes lasting weeks or even months. Although scientists are cautious about attributing human-like emotions directly to animals, these findings suggest that dogs may experience emotional responses resembling grief. The emotional connection between dogs and humans also produces measurable therapeutic effects. Therapy dogs are increasingly used in hospitals, nursing homes, and rehabilitation centers to provide emotional support to patients. Programs operated by organizations such as Pet Partners train dogs to interact calmly and gently with people experiencing illness, injury, or psychological stress. Studies have shown that interacting with dogs can produce measurable physiological changes in humans. Petting a dog can lower blood pressure, reduce levels of the stress hormone cortisol, and increase feelings of relaxation and well-being. For patients recovering from illness or coping with emotional trauma, these effects can significantly improve mood and overall health. Service dogs provide another powerful example of the partnership between humans and dogs. Guide dogs have assisted people with visual impairments for more than a century. One of the earliest guide dog training programs was established in Germany following the injuries of soldiers during World War I. Today, organizations such as the Seeing Eye train dogs to guide visually impaired individuals through complex environments such as city streets, public transportation systems, and crowded buildings. These dogs learn to navigate obstacles, stop at curbs, and respond intelligently to dangerous situations. In some cases, guide dogs must even disobey commands from their handlers if following the command would place the person in danger, a behavior known as intelligent disobedience. This remarkable level of decision-making demonstrates the depth of trust and cooperation that can exist between dogs and humans. Dogs also play an increasingly important role in supporting individuals with psychological trauma. Many military veterans living with post-traumatic stress disorder rely on specially trained service dogs to help manage symptoms such as anxiety, panic attacks, and hypervigilance. These dogs can interrupt distressing behaviors, provide grounding physical contact during episodes of anxiety, and create a sense of safety in crowded or unfamiliar environments. The benefits of dog companionship may even extend to long-term physical health. Studies conducted by the American Heart Association have suggested that dog ownership may be associated with reduced risk of cardiovascular disease. People who own dogs often engage in more regular physical activity because of daily walks and outdoor exercise. In addition, the emotional support provided by a companion animal may help reduce stress and loneliness, both of which are linked to long-term health outcomes. Taken together, these discoveries reveal that the relationship between humans and dogs extends far beyond simple companionship. Dogs have become helpers, protectors, caregivers, and emotional partners. Over thousands of years, the bond between the two species has grown into one of the most enduring relationships in the natural world. As this chapter comes to an end, the viewer begins to see dogs not merely as pets, but as partners who share human lives in profound ways. Yet the story of the human-dog partnership does not end with emotional connection alone. Throughout history, dogs have also demonstrated extraordinary bravery and dedication in moments of crisis, risking their lives to protect and rescue the people they love. The next chapter explores some of the most remarkable stories of canine heroism ever recorded. Stories in which dogs have saved lives, detected danger, and performed acts of courage that continue to inspire people around the world. Chapter 11. Dogs that became heroes. Throughout recorded history, stories of dogs performing extraordinary acts of bravery appear again and again in human accounts. From ancient legends to modern news reports, people across cultures have described dogs protecting children, rescuing travelers, and risking their own safety to assist humans in moments of danger. While some stories may seem exaggerated, many of these events are documented through official records, rescue reports, and eyewitness testimony. Taken together, they reveal a remarkable pattern. When humans face danger, dogs frequently respond with courage, persistence, and an apparent determination to help. These behaviors raise an intriguing question about the nature of the human-dog relationship. Why would an animal place itself in harm's way for another species? One of the earliest organized roles for heroic dogs developed in the mountains of Europe. For centuries, travelers crossing the dangerous passes of the Alps faced severe snowstorms, avalanches, and freezing temperatures. In the 17th century, monks living at the high-altitude hospice known as the Great St. Bernard Hospice began raising large working dogs to assist travelers who became lost or buried in snow. These dogs, later known as the St. Bernard, possessed thick coats, powerful bodies, and an extraordinary ability to detect human scent even in harsh winter conditions. The monks trained these dogs to accompany rescue teams searching for missing travelers during snowstorms. When the dogs detected the scent of a person buried beneath snow, they would dig vigorously until rescuers arrived. Over time, the St. Bernards became legendary throughout Europe for their rescue work in the mountains. One dog in particular achieved near mythical status. A St. Bernard named Barry served at the hospice during the early 19th century and reportedly participated in the rescue of more than 40 stranded travelers. Although historical details vary, Barry's reputation became so well known that his preserved body is displayed today in the Natural History Museum of Bern in Switzerland as a symbol of canine heroism. The role of rescue dogs expanded dramatically in modern times as organized search and rescue programs developed around the world. Today, specially trained dogs assist rescue teams in locating missing hikers, disaster victims, and survivors trapped beneath collapsed buildings. Their extraordinary sense of smell allows them to detect human scent through layers of rubble, soil, or snow that would otherwise conceal survivors from human rescuers. One of the most powerful demonstrations of canine dedication occurred following the September 11th attacks. After the collapse of the World Trade Center in New York City, hundreds of trained search dogs were deployed to assist firefighters and emergency responders working through the ruins. These dogs navigated unstable piles of debris, twisted metal, and hazardous dust in an effort to locate survivors trapped beneath the wreckage. Handlers later described how the dogs continued searching tirelessly despite extreme exhaustion and emotional stress. Some dogs even showed signs of frustration when they could no longer find survivors, illustrating the strong drive these animals possess to assist humans in distress. Bury skiers or climbers beneath deep snow. Bury skiers or climbers beneath deep snow. Survival often depends on how quickly victims can be located. Human rescuers searching with probes may take hours to find buried individuals. However, avalanche rescue dogs can detect human scent beneath several meters of snow and pinpoint the location of victims within minutes. Rescue teams in countries such as Switzerland, France, Austria, Canada, and the United States rely on these dogs to dramatically increase the chances of survival during avalanche emergencies. In addition to mountain rescues, dogs play critical roles in modern law enforcement and military operations. Military working dogs have served alongside soldiers in conflicts throughout the 20th and 21st centuries. During World War II, the United States and several other countries trained thousands of dogs for tasks such as sentry duty, scouting enemy positions, and detecting mines. These dogs accompanied soldiers into dangerous environments where their keen senses could detect threats that humans might overlook. In more recent conflicts in Iraq and Afghanistan, military dogs have become essential members of patrol teams responsible for detecting explosives. Improvised explosive devices are among the most dangerous threats faced by soldiers in modern warfare, and trained dogs can detect explosive materials through scent before a device detonates. Handlers frequently report that these dogs display remarkable focus and discipline even in chaotic environments, working calmly amid loud noises, unfamiliar terrain, and unpredictable conditions. Law enforcement agencies around the world also rely heavily on police dogs, commonly known as K9 units. These dogs are trained to perform a wide range of tasks, including tracking suspects, locating missing persons, detecting narcotics, and identifying explosives. Breeds such as the German Shepherd and the Belgian Malinois are particularly well suited for police work because of their intelligence, endurance, and strong drive to work alongside human handlers. Police dogs often operate in situations that would place human officers at considerable risk. For example, when suspects hide in buildings or wooded areas, a trained police dog may be sent ahead to locate and apprehend the individual. In these situations, the dog's speed, agility, and training allow officers to resolve dangerous encounters more safely. Not all heroic dogs serve in organized rescue or law enforcement roles. Many remarkable stories involve ordinary family dogs responding to emergencies in everyday life. News reports frequently describe dogs alerting families to house fires by barking loudly or pulling sleeping owners awake during the night. In other cases, dogs have protected children from aggressive animals or remained with injured owners until help arrived. One particularly striking example occurred in 1998 in the town of Kenai, Alaska. A man was involved in a serious car accident on a remote road and became trapped in the wreckage. His dog, a mixed breed named Babu, managed to escape the vehicle and run toward a nearby highway. The dog approached passing vehicles repeatedly, refusing to leave the road until a driver stopped. When the driver followed the dog back along the path it had taken, the injured man was discovered and emergency responders were able to reach the crash site in time to save his life. Dogs have also demonstrated extraordinary awareness during medical emergencies. Some dogs trained as diabetic alert dogs are capable of detecting changes in blood sugar levels by scent. In several documented cases, these dogs have awakened their sleeping owners during the night when blood sugar levels dropped dangerously low. By alerting their handlers before symptoms become severe, the dogs can help prevent life-threatening situations. Seizure alert dogs provide another remarkable example. Certain dogs appear capable of sensing subtle changes in their owner's behavior or body chemistry before a seizure begins. In response, the dogs may bark, nudge their owners, or position themselves nearby to provide support. Some dogs even learn to activate emergency alarms or fetch assistance during medical crises. These stories demonstrate that dogs are far more than passive companions in human environments. They actively participate in protecting and supporting the people around them. Whether trained for specialized roles or responding instinctively to emergencies, dogs repeatedly demonstrate a willingness to act on behalf of humans, even when doing so exposes them to danger. Across centuries of recorded history, these acts of courage and loyalty have reinforced the idea that the bond between humans and dogs is something truly extraordinary. Few other animals consistently display such dedication to another species. As this chapter concludes, a deeper question begins to emerge from these stories of bravery. Why do dogs form such strong attachments to humans in the first place? Why does this particular species demonstrate such an extraordinary willingness to cooperate with people? The next chapter explores an evolutionary explanation for this partnership. Scientists now believe that the relationship between humans and dogs may have shaped the survival of both species. Over thousands of years, humans and dogs may have evolved together, influencing each other's behavior, communication, and success in ways that continue to shape the world today. Chapter 12. Why dogs chose humans. The partnership between humans and dogs is so deeply woven into daily life that it can be difficult to imagine a time when it did not exist. Today, dogs live in homes, work beside people in hospitals and rescue teams, and share emotional bonds with families across nearly every culture on Earth. Yet for most of Earth's history, humans and wolves were simply two predators competing for the same food. They hunted the same animals, traveled through the same landscapes, and sometimes encountered each other as rivals. At some point, far in the past, however, that relationship changed in a way that transformed both species. Instead of competing, certain wolves began forming a relationship with humans that eventually gave rise to the domestic dog. Understanding how this extraordinary alliance formed has become one of the most fascinating questions in modern evolutionary science. For many years, scientists debated whether humans actively domesticated wolves or whether wolves domesticated themselves by adapting to human environments. Modern genetic and archaeological research suggests that the process may have involved a combination of both forces. Rather than a single moment of domestication, the transformation from wolf to dog likely occurred gradually over thousands of years through repeated interactions between humans and certain wolf populations. One of the most important clues comes from genetic research comparing the DNA of dogs and wolves. In 2013, scientists publishing research in the journal Nature identified genetic differences between wolves and domestic dogs related to digestion. The study revealed that dogs possess additional copies of genes responsible for breaking down starch, particularly a gene known as AMY2B, which helps produce enzymes used to digest carbohydrates. This discovery suggests that early dogs adapted to eating human food scraps, which often included cooked grains and plant-based foods. Wolves, by contrast, evolved primarily as carnivores and generally lacked the same ability to digest starch-rich diets efficiently. This genetic adaptation offers an important insight into how wolves may have initially begun interacting with humans. Early human camps produced food waste in the form of discarded bones, scraps of meat, and partially digested plant material. Wolves that were less fearful of humans may have begun scavenging near these camps. Those individuals able to tolerate human presence and capable of digesting the scraps humans left behind would have gained a survival advantage over wolves that remained purely wild hunters. Over generations, these scavenging wolves may have gradually become more comfortable living near human settlements. Natural selection would favor wolves that displayed reduced aggression and increased tolerance toward humans. Eventually, these animals would begin to differ both genetically and behaviorally from their fully wild relatives. In essence, the earliest dogs may have emerged not because humans intentionally domesticated wolves, but because certain wolves adapted to human environments. Archaeological discoveries also provide powerful evidence of early relationships between humans and dogs. In 2018, researchers studying ancient animal remains in Siberia uncovered evidence suggesting that dogs accompanied humans across the Bering Land Bridge more than 15,000 years ago. This ancient land bridge connected Asia and North America during the last ice age, allowing humans and animals to migrate between the continents. The presence of dog remains alongside human migration routes suggests that dogs were already companions to humans before the first people entered the Americas. Another remarkable archaeological discovery comes from a prehistoric settlement known as Ain Malaha. Excavations at this site revealed a burial dating back approximately 12,000 years in which a human was buried with a puppy resting in their arms. The careful placement of the dog in this burial suggests that the animal was not simply a working companion, but likely held emotional significance for the person it was buried with. This discovery indicates that the human-dog bond may have already included emotional attachment long before the development of agriculture or permanent settlements. Anthropologists studying early hunter-gatherer societies believe that dogs may have offered humans several practical advantages that strengthened this relationship. Hunting was one of the most important survival activities for early human groups, particularly during the Ice Age, when large animals such as mammoths, bison, and reindeer dominated many ecosystems. Wolves are highly skilled hunters, capable of tracking prey over long distances using scent and cooperative pack strategies. If early wolves and humans occasionally hunted in the same areas, it is possible that both species began benefiting from each other's presence. Wolves might detect the scent of prey animals and begin pursuit, while human hunters could use weapons such as spears to bring down animals once they were cornered or exhausted. In return, wolves may have gained access to leftover portions of the kill. Over time, this loose cooperation may have evolved into a more consistent partnership. Modern research into hunter-gatherer societies supports this possibility. Ethnographic studies of traditional hunting communities show that dogs can dramatically increase hunting success rates. Dogs can track animals through dense forests, locate wounded prey that might otherwise escape, and assist in driving animals toward hunters. In some environments, the presence of dogs can make the difference between a successful hunt and an empty-handed return. Dogs may also have provided an additional benefit that early humans desperately needed: security. Human camps during the Ice Age were vulnerable to predators such as large cats, bears, and rival human groups. Wolves possess highly sensitive hearing and smell, allowing them to detect approaching animals or strangers long before humans become aware of danger. A barking dog could serve as an early warning system, alerting an entire camp to threats during the night. Researchers at institutions such as University of Arizona and other academic centers have suggested that this combination of hunting assistance and security may have given human groups with dogs a survival advantage over groups without them. Communities that cooperated with dogs may have been more successful in hunting, more protected from predators, and better able to travel through unfamiliar environments. In Arctic regions, dogs later became essential for transportation as well. Sled dogs allowed humans to travel across frozen landscapes that would otherwise be nearly impossible to cross on foot. These dogs pulled sleds carrying supplies, food, and people across vast stretches of ice and snow, enabling human expansion into some of the most extreme environments on Earth. Over time, the partnership between humans and dogs evolved far beyond simple cooperation. Dogs became integrated into human families, villages, and cultural traditions. Archaeological records from ancient civilizations show that dogs were present in many aspects of daily life. In ancient Egypt, wall paintings frequently depict dogs accompanying hunters or resting beside their owners. In ancient Mesopotamia, dogs appeared in religious symbolism and were sometimes associated with healing deities. In classical Greece and Rome, dogs appeared in literature, sculpture, and household life as companions and guardians. Dogs even took on spiritual significance in some cultures. In certain mythologies, dogs were believed to guide human souls to the afterlife. In ancient Egyptian belief, the jackal-headed god Anubis was connected to burial rituals and the protection of the dead. These symbolic roles reflect the deep emotional and cultural presence dogs had already established in human societies thousands of years ago. What makes the human-dog partnership especially remarkable is that it appears to have shaped the evolution of both species. Humans influenced the physical and behavioral traits of dogs through selective breeding and long-term cooperation. At the same time, dogs influenced human societies by improving hunting success, enhancing security, and providing companionship that strengthened social bonds within communities. The deeper scientists study this relationship, the clearer it becomes that dogs were not simply domesticated animals created by humans. Instead, they may represent the result of a shared evolutionary journey in which two species gradually learned to live, work, and communicate together. As this chapter comes to a close, one final question begins to emerge. After tens of thousands of years evolving alongside humans, dogs remain one of the most important animals in human life. Yet even today, scientists continue to discover new aspects of canine intelligence, communication, and sensory ability that challenge our understanding of animal cognition. The next and final chapter explores where this extraordinary partnership may lead in the future. As researchers continue unlocking the mysteries of the canine mind, dogs may help humans make discoveries about communication, medicine, and even the nature of intelligence itself. Chapter 13. What dogs may still be hiding. For thousands of years, humans have lived beside dogs, hunted with them, slept beside them, and relied on them for protection and companionship. Few animals have shared human history as closely as the domestic dog. Yet despite this long partnership, modern science is only beginning to uncover the full scope of what dogs may be capable of. Every decade seems to reveal new abilities, new ways dogs perceive the world, communicate with humans, and process information. Researchers studying canine cognition increasingly suspect that the dog's mind may be far more complex than earlier generations of scientists imagined. In laboratories around the world, scientists are now exploring questions that would have sounded almost impossible a century ago. Can dogs truly understand elements of human language? Do they possess memories that resemble human episodic memory? Can their vocalizations carry structured meaning? Could technology eventually allow humans to translate aspects of canine communication? These questions sit at the frontier of modern canine research, and the answers may reshape how humans understand one of their closest animal companions. One of the most important research centers investigating these questions is the Duke Canine Cognition Center in North Carolina. Founded by cognitive scientist Brian Hare, the center studies how dogs think, learn, and communicate. Researchers there conduct experiments examining how dogs interpret human gestures, solve puzzles, remember past events, and respond to social cues. These studies suggest that dogs possess a sophisticated form of social intelligence that allows them to read human behavior with remarkable accuracy. Another major research program operates at Eötvös Loránd University in Budapest, where scientists have conducted pioneering work on canine brain function and cognition. Using non-invasive brain imaging techniques, researchers have studied how dogs process language, tone of voice, and emotional signals. These experiments revealed that dogs possess brain regions specialized for interpreting vocal tone, allowing them to distinguish between praise, neutral speech, and disapproval. In some ways, the canine brain appears uniquely adapted for interpreting human communication. Yet even as these discoveries accumulate, many aspects of canine communication remain poorly understood. Unlike humans, who rely heavily on spoken language, dogs communicate through a combination of signals, including body posture, scent, facial expression, and vocal sounds. A wagging tail, raised ears, a slight change in posture, or a low growl can all carry meaning within canine interactions. Researchers increasingly believe that dogs may possess a communication system far richer than humans typically recognize. One area receiving growing attention is the study of canine vocalizations. Dogs produce a wide range of sounds, including barks, whines, growls, yelps, and howls. For decades, these sounds were assumed to represent simple emotional reactions rather than structured communication. However, studies conducted by bioacoustic researchers have shown that humans can often distinguish different emotional meanings within dog barks, even without training. For example, people can usually recognize the difference between an alarm bark, a playful bark, and a bark expressing loneliness or frustration. Scientists are now attempting to analyze canine vocalizations using advanced acoustic analysis and machine learning. By studying patterns within thousands of recorded barks, researchers hope to determine whether dogs produce distinct vocal signatures associated with particular emotional states or environmental situations. Some early studies suggest that certain patterns of barking may contain more structured information than previously assumed. Artificial intelligence is beginning to play an important role in this research. Several technology companies and academic groups are developing wearable devices designed to monitor canine behavior in real time. These devices can track movement patterns, heart rate, body temperature, and vocalization frequency. By analyzing large data sets collected from dogs in everyday environments, researchers hope to identify patterns that reveal how dogs respond to different stimuli. One goal of these projects is to develop systems capable of translating aspects of canine behavior into information humans can understand, while a true dog translator remains far in the future. The combination of machine learning and behavioral analysis may eventually allow humans to interpret canine emotional states with greater precision. Such technology could help veterinarians diagnose illness earlier, or assist trainers in understanding how dogs respond to different environments. Another area of growing interest involves canine memory and perception of time. For many years, scientists believed that animals lacked episodic memory, the ability to recall specific events from the past. However, experiments conducted by researchers in Hungary and Japan suggest that dogs may possess a form of episodic-like memory. In one series of studies, dogs were trained to observe human actions and later reproduce them after a delay. The results indicated that dogs could remember actions they had witnessed earlier, even when they had not been trained specifically to memorize those actions. This ability suggests that dogs may possess more sophisticated cognitive abilities than previously assumed. Rather than living entirely in the present moment, dogs may be capable of recalling past experiences and adjusting their behavior based on those memories. Such findings challenge earlier assumptions about the limits of animal cognition. Medical research involving dogs continues to reveal equally surprising abilities. Earlier chapters explored how dogs can detect certain diseases through scent, including cancers, infections, and metabolic disorders. Scientists are now expanding this research to investigate whether dogs can identify additional illnesses through scent signatures. Research programs at institutions such as University of Pennsylvania and Auburn University are examining how canine scent detection might complement traditional medical diagnostics. In some experimental trials, dogs have detected diseases earlier than existing laboratory tests. If scientists can identify the chemical compounds dogs are detecting, future medical technologies may replicate these abilities in electronic sensors. In this way, the canine nose could inspire new diagnostic tools capable of detecting illness long before symptoms appear. Dogs are also playing an increasingly important role in psychological therapy and emotional support. Research conducted in hospitals, universities, and mental health clinics shows that interacting with dogs can significantly reduce stress and anxiety in humans. Programs involving therapy dogs are now common in schools, hospitals, rehabilitation centers, and even courtrooms where victims of trauma may need emotional support while testifying. In the field of disability assistance, service dogs continue to demonstrate remarkable versatility. Guide dogs assist visually impaired individuals in navigating crowded city environments. Hearing dogs alert owners to important sounds such as alarms or doorbells. Mobility assistance dogs help individuals retrieve objects, open doors, and maintain balance while walking. As training techniques improve, service dogs are being prepared for increasingly specialized tasks. Researchers have also begun exploring how dogs interact with digital environments. Some studies have shown that dogs can recognize their owners' faces on screens or respond to voices transmitted through speakers. Experiments involving video calls have even suggested that some dogs recognize familiar individuals when they appear on screens. As digital technology becomes more integrated into daily life, scientists are beginning to ask how dogs perceive and interpret these artificial environments. Another fascinating question involves how dogs perceive the emotional lives of humans. Behavioral experiments suggest that dogs can detect changes in human mood through facial expressions, vocal tone, and body language. Some researchers believe dogs may also detect chemical signals associated with stress hormones such as cortisol. This combination of sensory cues may allow dogs to respond to human emotions in ways that appear almost intuitive. Despite the extraordinary progress scientists have made in recent decades, the canine mind remains only partially understood. Dogs occupy a unique position in the natural world. They are neither entirely wild animals nor completely human creations. Instead, they represent the result of thousands of years of shared history between two species that gradually learned to cooperate. Humans shaped dogs through selective breeding, training, and companionship. At the same time, dogs shaped human civilization by improving hunting success, providing security, and offering emotional companionship that strengthened social bonds within communities. Few other animals have influenced human history so deeply. As this final chapter begins to draw the story together, one truth becomes increasingly clear. The partnership between humans and dogs is not simply the result of domestication. It is the product of a long evolutionary journey in which two species adapted to one another in ways that continue to shape their relationship today. At the beginning of this story, dogs seemed capable of sensing illness, predicting events, and understanding human behavior with uncanny accuracy. Throughout the journey, science revealed many explanations for these abilities. Dogs possess extraordinary sensory systems, powerful learning capabilities, and brains uniquely adapted to interpreting human signals. Yet even after all that knowledge, something about dogs still feels mysterious. They remain one of the very few animals capable of forming deep emotional connections with humans across cultures and generations. In homes around the world, dogs watch their owners leave each morning and greet them again each evening with unmistakable excitement. They respond to our voices, notice subtle changes in our moods, and remain beside us through the quiet routines of daily life. From ancient wolf packs roaming Ice Age landscapes to modern households filled with companionship, the story of dogs is ultimately the story of two species evolving together. Somewhere along that long path, wolves became something new, animals capable of understanding humans in ways no other species ever had. And perhaps the most remarkable part of that story is that even today, after thousands of years living side by side, dogs may still understand us better than we understand them.